one of the FRQs this year is going to be to design the beginnings of an experiment. And so you will have to identify variables, state a hypothesis, and explain how the experiment might work. They might also give you some data and you'd have to analyze that. Observations are gathered through our senses. I have an interesting scenario here. Does anybody know the location of these images?
Death Valley.
Thank you, that's correct. Death Valley in California, and it is called Racetrack Playa. You can see these stones, which it's hard to gain perspective from these images, but these stones are quite large, and they appear to have tracks, as if they've moved. So we can use the scientific method to go after what's actually happening here. Can somebody offer me an observation based only on those pictures? Remember, we're only using our senses here. Go ahead, I see your hand up.
There's mountains.
That is an observation. Excellent. There are mountains.
There are no footprints around.
In these images, we do not see footprints. Yes, I agree. Observation. Anytime that you say the rocks have been moving fast, well, that's an inference. We don't know that. It appears that they might be, but we don't have direct observational evidence of such. If you said the rocks are moving far, well, once again, that's an inference based on the observations that we've made. Now, if you say the trails or the tracks, if we call them that, the imprints, if you will, are not all in a straight line. That's an observation, right? These lines that we see are not the same direction or in the straight line necessarily. This is real. In Racetrack Playa in Death Valley, we think these rocks are moving. The question is, how and why? And that's the next part of the scientific method, right? We want an answer now. We want to know what's going on here. So we take those observations, we make inferences based on that, and we then discuss it until we reach what are called facts. Once we are able to experiment with facts and add some mathematical backing to that, we can formulate what is called a law. The ultimate pinnacle of science is what we call a theory. As a theory means that it has been tested over and over and over and has not been disproven. When we get to the level of theory, it is supported by facts and laws. And you can see the example down below. Matter is comprised of atoms. That's basic. It explains how gases behave. Remember the ideal gas laws, PV equals nRT. Chemical reactions occur. Those can be explained by formulas. And the periodic table is arranged by observable properties. All that put together explains atomic structure, the theory of atomic matter. Okay? We're going to talk about plate tectonics very soon. Plate tectonics was a theory, or is a theory. We use facts and experiments to prove it. So when we say, I have a theory about that, we're not really saying the right thing scientifically. We should say, I have a hypothesis about that. A hypothesis is your idea that has not been tested yet. If you say, I have a theory, you better be 100% sure about it, because that's what it means. Okay, so let's end the lecture portion today with a very quick test. My friends keep saying theory when they should be saying hypothesis. If the rotation of the Earth stops, then life cannot exist. Is that a fact, a hypothesis, or a theory? One thing that gives away a hypothesis is anytime you see the relationship of if, then. We usually add because to it. If and then. If you see those words, you're dealing with a question, something that needs to be tested. If this happens, then this happens. Cause and effect, right? Could we test the existence of life if the Earth stops rotating? Well, we couldn't do it to the actual Earth, but could we model it in some way? Even with computers? Probably. Okay. Planets move in elliptical orbits as explained by Kepler's laws. Is that a fact, a hypothesis, or a theory?
Theory.
That is the theory of orbital mechanics, yes. The way that planets go around the sun is backed up by observable facts and a whole bunch of brilliant math from a guy named Kepler. The Earth is a sphere.
Fact.
Yep. Almost everybody would agree to this statement. It's simple. We could back it up with mathematics and observations, but we haven't said that in this statement. Okay? So those are the basic differences between those three terms.